The OSI model was created by the International Organization for Standardization. The OSI model itself was introduced in 1984 and was used and upgraded for the next 10 years. This model gave a set of unique, like terms to simplify conversations about different networking technologies. Today, we will be talking about the OSI model and its layers, giving a description of each. There are 7 total layers that make up the OSI model. These layers are the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The layers 1 through 3 are usually referred to as the lower levels, whereas layers 4 through 7 are considered the upper levels. As I just mentioned, the first layer of the OSI model is the physical layer. In this layer, the physical characteristics of the network are laid out. These physical characteristics are the electrical, mechanical, procedural, and functional specifications for activating, maintaining, and deactivating the physical link between systems. What this means in layman's terms is all the things concerning cable types, lengths, connections, volts, and data rates, etc. The second layer is the data link layer. This is the layer that deals with physical addressing and transmitting data over a physical link. In this layer, each device is assigned its own address called the Media Access Control Address, or MAC address for short. This addressing system is very important because it is examined by switches on a network to direct the packets of data where to go. The data link layer also uses the Ethernet protocol to transmit data in such a way that the packets do not get hung up by interference from other devices sending packets over the network. Layer 3 is the network layer. This particular layer is responsible for routing messages on the network from one computer to another. The 2 most common protocols associated with the network layer include IP and IPX. These protocols set up standards for logical addressing, which enables you to choose your own IP address. The address can be static or dynamic. To have a static IP address means that the device keeps the same address. A dynamic IP address is one that is assigned to the device when it connects to the network and then unassigned when it is no longer connected to the network. If you have ever seen the abbreviation IPv6, you are not going crazy. It is a newer version of the IP protocol that enables more IP addresses to be assigned to more devices. The process of this layer finding the correct path through the maze of the network using these protocols is called routing. This is done through a device called a router, which sends the packets to the correct network. The fourth layer is the transport layer. The transport layer is responsible for defining error recovery services and breaking larger amounts of data from the session layer into smaller packets of data. The protocol that takes care of all of these tasks is called the Transmission Control Protocol, or TCP for short, which is typically paired with the Layer 3 IP protocol. The main purpose of the TCP is quickly moving the data over the network without errors and reassembles the message at the end. The fifth layer is the session layer. The session layer's only job is to create and stop sessions between 2 host computers while managing their data exchange. It can keep track of 1 or more connections at a time and is started when a download is requested. By managing the newly opened session between the server and the client, it organizes each session, if there is more than one, and keeps track of which data belongs to which file. After the said download is complete, the session is ended between both computers. The sixth layer is the presentation layer. The presentation layer is responsible for translating data between different formats, encrypting and decrypting files. Some of the data standards associated with this layer include JPEG, PICT, and TIFF for pictures, and MIDI and MPEG for movies and sound. To encrypt the data being sent, this layer uses encryption software to scramble the message being sent. If someone were to see the encrypted data without decrypting it first, it would look like a pile of gibberish. The numerical code in which the data is scrambled is called an encryption key and is used to decrypt the data with the matching key found from the recipient. If the keys match, the data will be unscrambled and readable to the recipient. Last but not least, we've made it to layer 7, the application layer. This layer doesn't necessarily mean it's an application like a program you'd run on your smartphone, but it's more on how the programs interact with the network and outside the OSI model itself. The most common standard associated with this layer of the OSI model is Hypertext Transfer Protocol, or HTTP for short. Since the standard HTTP should sound very familiar to everyone, it's no surprise that the internet browsers are one such application that communicates with the network and other outside devices. Even though the OSI model isn't as prominent as it used to be, it gave networking professionals a set of unique terms that are still widely used today. The concepts we've covered today are very important to learn because they were, and still are, building blocks that newer, more improved protocols have been built around. Without mastering these basic fundamentals, you'll never be able to move on to the newer aspects of networking.